Welcome to the presentation of the traditional climate change education material of our project PARCCE. In the introduction, we present the brief overview of the importance of climate change education and also the objectives of the PARCCE education activity. In the understanding of the climate change and its impacts, we'll explain what is it, does it really exist, because there are still people, very few, questioning that, and how much does it affect us, which is all are important for the understanding of the issue. I start by explaining the difference between climate and weather. There is a major difference. Climate is in fact the average weather condition that prevail in an area for a long period of time. And this is documented by observations, usually of sometimes of centuries or at least many decades. So this allows to give the climate its seasonal fluctuations and also the margins of the changes, showing the stability over time. It differs climate from weather. Weather is what we listen every day in our radios or TV, which explains the temperature, wind, humidity of the next days. And this is not the climate, because you have, for example, some days of high temperature, some days of low temperature or high precipitation. So the climate is shaped by many factors. The sunshine, the latitude, the proximity to the sea, and big areas of water giving, vapors. Also the plant cover of vegetation, the proximity to cities, etc. All these play with, at the end of the day, with temperature and humidity as major characteristics. And this allows to have zones of different climate. So the cold polar zones, the very warm zones near the equator, and also the ones we have in the northern and southern hemisphere, which are in between the moderate climate. The climate has changed radically many times since the formation of our planet 4.5 billion years ago. These fluctuations between warm and cold periods, sometimes lasting for many thousands or millions of years, were due almost always to climate variations. The only, and in some cases, some extraordinary events, falling of asteroids and these kind of things. The changes, these changes were actually based on the photosynthesis. So the existence of no plant cover in our Earth, and also in the phytoplankton in the seas. The last period of ice, the last ice period, was about 20,000 years ago. For the past few millennia, the climate has been fairly stable. Only in the last 150 years, the period that coincides with the so-called industrial era, after the industrial revolution in the late 18th and 19th century, global temperatures have gradually increased faster than in any other period in the past. And we can see this in this figure. In this figure we have global average temperatures from 1850, which is the period when we started the Industrial Revolution, and with the Industrial Revolution the use of fossil fuels, particularly coal. And here we have different sets of data, and usually we have a center running 60-month periods, 5-year periods here in creating this graph, which is quite accurate, at least in the last let's say 100 years. So you see the difference. We have a difference, significant increase from 1940s, after the war, let's say, after the war, so the Second World War. And this is due to the use of fossil fuel, particularly oil, petrol. It is therefore today a very strong scientific consensus that the Earth is warming rapidly, and this warming is caused mainly by human activities. The main factor is the CO2, the carbon dioxide, and the greenhouse gases resulting, the emissions resulting from burn of fossil fuel. We have, as you know, the Intergovernmental Panel of Climate Change, working under the auspices of the UN, which has confirmed that the climate change that we observe today is of anthropogenic origin. What is important is that we already have undeniably an increase by 1.36 degrees centigrade from the pre-industrial period, approximately 1850. Some claim that we have more than that. The difference is 141 degrees centigrade. It's important to even this small difference, because we need to have not to exceed the 1.5 degrees centigrade in order to avoid major problems, as we'll see in the next slides. And actually, this is something that is still feasible if we try hard, much harder than what we have done until now. Here you can see that January 24, 2024 was the warmest in series month in record. This is very alarming, because you see how the temperatures increase in the period after the war, 1948 to 24. And particularly in the last 25, 30 years. This is also an alarming figure because we can see that in the last few years, from 2019 onwards, we have very high temperatures recorded in all our region, throughout the planet, but particularly in our region, which is very vulnerable in the Mediterranean, but also Europe. You see that the dark brown, reddish brown parts exhibited the warmest on record temperatures ever. And then you see that the slightly less dense is the second warmest, or third, fourth, fifth, sixth on record temperature. And when we are talking on record, we are talking about temperatures that we know we are certain about. So we know well that these are, at least for the period we are talking about, the highest temperatures. And these are followed by low precipitation or extreme events. I mean, after a period of high temperatures, you have sometimes storms or floods. What is even more alarming is the ice cap, the loss of ice because of ice melting. You see the whole area presented is what we have in the Arctic Ocean. And in less than 50 years, we have something that is recorded there as 2012. This is the only part we still have a frozen cap, and actually since 12, in the last, let's say, 13 years, we lost even more. And this is what we had in 2012, and since then we have a decrease. I have to say that this change is almost irreversible, at least with the conditions we know until now. And the results of this for global warming, but also for biodiversity and all other issues related to this change are irreversible. The problems will remain and will be for us to address in the coming years. And in fact, the melting of ice cover, snow cover, ice caps result also in floods, because this water was not part of a harmonious water cycle. So you have extra water in these areas, and it's not only melting. We have to understand that a lot of the ice cap or snow loss is due also to mechanical changes, destabilization, fragmentation of the solid surfaces, and therefore we have also mechanical dissociation of the different parts and fast melting then. So what you see here with the blue line are the number of events of extreme storms and floods, and the dots are actually fatalities, loss of people. And you can see that in the period after, let's say, 1990 to our days, we have a very, very significant increase of both. And here you can see the dry winter periods. I mean, we have here the period 1991 to 2020 with droughts in the region of the Mediterranean. So you see precipitation anomalies during the so-called dry winters. And you see where you see the dark color, you have very high anomalies, the values showing very dry winters, while in the white areas you have the water expected, so you don't see the drought so much. So in this one you see that the drought is mostly, in this at least period, in the Western Mediterranean. We are talking about winter periods with less precipitations. And what this picture presents are the forest fires. When you have dry winters, when you have high temperatures, the biota, trees, grass, everything become dry, become more, they catch fire easily. And what you see here, the shadow behind shows the cumulative period 2006 to 2023, and the line in red is what we had in 2023, which was a particularly extraordinary dry year. And you can see exactly, I mean, this phenomena, the how extreme conditions we have to address, perhaps also more frequently in the future. Extraordinary conditions that actually led to many fires, and you can see here the different dots, the bigger and black and more brown intense color you see are more important fires all around the Mediterranean. In fact, you see that in Greece alone, in July to August 23, we had 960 square kilometers, which is twice the size of Athens, all metropolitan area, which is the largest wildfire ever recorded in the European Union. And you see that also how the high percentages affected by strong, very strong, and extremely strong heat waves in July 23. So 41% of the population. So these are unique in record conditions that undoubtedly are linked to the climate change. This again, you see from a series of records by many different laboratories, the daily temperatures, not only on the surface atmosphere temperatures in the surface of Earth. We have also anomalies, very high temperatures at the surface of the sea. And I have to remind you that the sea is one of the best regulated from the point of temperature system we have on our planet. And because of that, we have the stability we had all these years. And you see that in winter, 23rd of winter, January of 23, we have an extraordinary high temperature, which is unique for the period 1980 to 2023 that we present here. This was recorded in northeastern Atlantic Ocean. And here in the Mediterranean, we see also something similar recorded in summer between 8th and 26th of July 2006. You see in the two pictures a change of 8 degrees centigrade within these days, within less than 20 days, in the western part of the Mediterranean. And because of the fact that the sea is very well regulated and has no big fluctuations, the ecosystems, the marine ecosystems, are very vulnerable to this kind of changes. So what you see here is a picture of the benthic species, biota, in this area before the event. And this is what happened after that. Mass mortality of more than 75% of invertebrates and many other species. So you understand that we are talking about, here is a clear demonstration of the impact of climate change and the changes also in the marine environment to the biodiversity, reducing the biodiversity in a rapid way. Again, what is the temperature? What is the cause of the temperature increase? In fact, as we say, are the gases, the emissions from burning fossil fuel, and also some other anthropogenic gases like nitrous oxide, chlorofluorocarbons, gaseous compounds. All these have, in the last decade, cumulative fluxes of huge, really huge quantities. We are talking about, you see, something like 5,000 teragrams of carbon in the atmosphere from carbon dioxide. When we are talking about teragrams, imagine that 10 in the sixth is are millions. Here you have 10 in the 12. So to understand this is extremely difficult to imagine the amounts. The same is for methane, for nitrogen, nitrogen hypoxide, and other gases, but these are the most important. And these fluxes continue despite these emissions, despite our efforts, because our efforts are fragmented. And I come back to that in a minute. Here are the graphs that show this increase. You see that from the period of 2000 to our days, we have jumped already from 370 or something to 420 in carbon dioxide, and also similar increases in methane. Again, the IPCC emphasized that we won't achieve the critical emission reduction goals without stopping deforestation and restoring the world forest. You see, you have to understand, from the one hand, we produce more greenhouse gases. On the other, we reduce the trap of this, because through photosynthesis, as you know, plants take the carbon dioxide and develop their leaves, the biomass. So we have both, we need both to reduce the emissions, but also increase or at least maintain the traps of CO2. And here we have loss again. So for this reason, there was an agreement for restoration of forests, which are unfortunately very far from being achieved until now. And as I said already, long periods of droughts reduce the moisture in flora, grass, forests in general, and the drier they become, the easier is to catch fire. Here you see how far we are from the goal. We had the goal to reduce actually the loss of plant cover, of tree cover, by 2020, to have it 10 million. And instead of that, we, from 2000, at 2000, it was more easy to go from less than 15 to 10. Now we have reached more than almost 30 million, more than 25 million, and the goal is to go beyond 5 million in 2030. We have only 5 years to reach this goal, and I may predict that we will not actually reach this goal. All these add problems in addressing the long-term vision and the target to avoid catastrophes. In 2024, the European State of Climate Report informed us about the effects of climate change and the impact of the climate change and the high temperatures on millions of people in Europe, both on their health, property, and living in general. And all the extreme weather events related to unprecedented heat waves, very high increase of sea temperature, not only at the surface but also in deeper strata, as I indicated before. So the question again by many people was, what is new? Why we have this new very extreme phenomena? The answer is we are changing drastically the composition of the chemistry, the composition of the atmosphere, adding too many greenhouse gases there and enhancing the greenhouse effect. Let me explain a little bit this greenhouse effect, because in the past we had this, and it helped us to keep a livable, environment, livable conditions in the planet. Now, so we always had a greenhouse layer that trapped part of the radiation and increased the temperatures. Now, this phenomenon has become a big problem. Let's follow the agricultural greenhouses, where we have glass or plastic. The sunlight reaches the glass. To a certain extent, this is reflected back, and an important part penetrates the glass or plastic, warms the plants, and in fact, we have from the soil and the plants also reflection, but of the part of the radiation which cannot penetrate the glass, which is the infrared part of the radiation. So the role of the glass or plastic is played by the layer of greenhouse gases. So this part continuously is becoming more dense, enriched in this kind of components that do not allow the radiation reflected from the surface of the Earth to go to the space. If we can see it here, the natural greenhouse effect, you see that we had the solar radiation and first a part of the reflection, and also the part of the heat that escaped into the space. Now, on the right-hand side, we see that with the brownish color represent the existence of more greenhouse gases that is mostly CO2, methane, nitrogen hypoxide, even vapors. So this trap actually the temperature within this area and allow less heat to escape into space. So this is the reason why we have this problem, and from a moment, I mean, when you reach a critical concentration of these gases in the atmosphere, the phenomena become obviously more severe and the extreme events more frequent. We have to remember, I give you few percentages, that from the sun, 19% of the radiation that reaches the Earth is absorbed by the atmosphere, 47% is absorbed by the ground, and almost 37% is reflected back into space. So in fact, we are talking about this 37% that is reflected back into the space that now is increasing. So these greenhouse gases trap the heat in the atmosphere, preventing actually this escaping into space part of the temperature of heat, increasing the ambient temperature. This is how we explain easily this change, because you have to remember that from 180 to 280 ppm of carbon dioxide that we had for long periods. Now we have, within the period from the end of the 18th century, 1750 approximately, a 150% increase of this concentration. So today we are reaching 420 ppm. We can see that in this graph. You see that from here are thousands of years before today, and how we can know these temperatures is through measurements we have in carots, in cores of sediments or ice going back to this era. And we have many ways to follow that, also taking into account the different fossil animals, fossil biota, and also bubbles of air that have been trapped there. And when we melt, we liberate these gases, and we measure, so we know well that these are actual situations. So you see that from 800,000 years, till almost 400, we had less than 260. We have, let's say, in the last millennia, in the last thousands of years, hundreds of thousands of years, percentages, concentrations of CO2 around 300. And now you see from 1911, and particularly after 1945, you see the temperature almost, within few years. So in the graph, it is all in millimeter. We have all this increase, and the last part is also monitored and measured with modern instrumentation. There are modern instrumentation methods. So you understand that such a rapid change of temperature of CO2 is followed by rapid changes in temperature, and also all kind of phenomena, because within these few years neither the biota nor other systems in nature can actually react and follow or mitigate this increase. Here we have, as you can see, 6 very respectable organizations or systems, scientific systems, following the changes in temperature in the last years, from 1850 to our days. And you see that all of them agree fully in the fluctuations and the temperature presented. You see that we are reaching the 1.5 degree, which is considered as the maximum tolerable change that will not cause extreme events and difficulties in the future. This graph is of particular importance because, as you can see, we have calculated all the natural sources and impact of the natural sources in temperature, namely solar changes, because we have eruptions, we have different phenomena changing to a certain extent the solar radiation to a less degree than what we thought in the past. We have also taken into account natural variability connected also with phenomena related to plants and changes in the plant cover and other things, and also the volcanic eruptions. You can see that with all this variability, we don't go away from zero, almost zero, which is the situation before the Industrial Revolution. So the natural causes have a variation, but practically the mean change is insignificant. So all the blue line is attributed to the human forces, to the human intervention. And this is undeniable. Now let's see how we can address this issue. We have different scenarios trying to avoid irreversible catastrophic consequences. If we continue the business as usual, we'll have 4 to 5 degrees changes by the end of the century. And this means irreversible, really totally devastating conditions. You see the different scenario, and what we want is the one under the blue line, which secures that we don't have more than 1.5 degree increase. Practically is taking into account uncertainties. This means almost up to 2 degrees centigrade. What we know is that we have already some positive results. I'll show you, and this is very optimistic that when we take measures, we have impacts good for the future. However, we are far from doing the right thing and enough. And this means that we need approximately $100 billion per year in order to achieve what we have planned, with a scenario that we prefer the 1.5 degrees centigrade change. Here is what we have. If you have no climate policies, you see that we risk to have 4.1 to 4.8 increase in temperature. With the current policies already in the pipeline, if we continue them, we may have 2.5 to 2.9. And if the pledges are, the existing pledges are implemented, we may have 2.1. We need a little bit more effort in order to be on the safe side. Unfortunately, among the pledges and the current policies were also the commitments of the United States that at this point have been actually taken back. The root causes, after all, and this is very important to understand in climate change education, is that the huge amount, the main root are the huge quantities of fossil fuel burned. And there is no other way to approach this issue without removing these emissions. On the other side is also the decrease of the forests, wetlands, and plant cover excuse me, on Earth. We can see the distribution among the different activities. So 31% of the emissions are attributed to the production of electricity. A very big part, some 15% of the emissions, are connected to transport, and 12% to the manufacturing and construction. So these are the three, as you can see, most important sources of activities, followed by other fuel combustion, fugitive emissions, other industrial processes, an important 11% due to agriculture and particularly management of manure and also respiration. It's animal or is an animal origin of these emissions. These are closely linked with the needs of the humanity, and this is connected to the overpopulation, to rapid increase of the population, consumerism, which introduces artificial needs, totally, let's say, manipulated, lack of awareness, which allows for that, lack of awareness and education, and also political inertia for effective short-term and long-term solutions. As we can see in the next slide, the human population for millennia till the start of the Industrial Revolution was less than 1 billion people. In approximately 1820, we have the first billion, and you see that the second billion occurred in another 100 years, in 1920 to 30, and since then we have the third billion in 1960, and till then we have reached almost or exceeded 8 billion now. So we are talking about an increase where no species, no other species has such an increase without having problems of eventually extinction. And there are several models that have predicted a decrease of the population. I think we will see it very soon, but not because of planning and management, but only because of collapses of the governance on Earth. And this is, when we start seeing this, we are going to have a no return point. So we are also alarmed by this graph. It's also very important to see that in the Western world, but not only now, but throughout, we have this phenomenon of excessive consumerism, largely of unnecessary goods and services, and followed by a very rapid increase of waste, all kind of waste generation in millions of tons. You can see that from 2000 on, we have and we predict to continue having a very rapid increase of waste material, waste after the use of material. This is the blue line here, the main line here is the linear model of production and consumption, which prevails today. So from energy and material use, we have the production, we have the distribution of goods, we have the use of goods, and then we have just a disposal. We throw the material together with the used item in the garbage. And this waste actually generates all kind of emissions in the atmosphere, but also in the waters and all the rest, distribution, plastic pollution, everything. What we need in order to go back and reduce the problems closely related with the emissions are also is also the reuse. First of all, from the disposal, we need to reuse, refurbish, remanufacturing, and recycle, so that we close the loop, having what we call actually the circular economy. And as you can see there are different steps, including the longer use of products, what we call dematerialization, decreasing the material, the mass of different materials we use. To give you a very clear example, all the construction demolition waste we have, which is actually thrown in the coast, in wetlands, in rivers, causing secondary problems with floods and all these kind of things, to a large extent can be reused instead of having new material from earth, from quarries and all the rest. So all this has to be redesigned, and from the beginning take care about criteria of safety and quality that can encourage, with incentives, encourage the reuse of the waste material. In fact, the circular economy, the optimum goal of that is the so-called zero waste system, and there are already also voluntary schemes in some cities, in some countries, to move towards this zero waste. Some islands, small islands also in Greece, have adopted this zero waste principle, which is of course very ambitious and requires enabling conditions for this green transformation, as agreed already in the United Nations, and to a certain extent are reflected in the so-called 7 Sustainable Development Goals that we need to reach by 2030. Here is actually the target agreed at the given moment for 2030, that in big cities we should not have more than 4.7 equivalent to CO2 per capita. And you see that many of the cities, particularly in the United States and other countries as well, including regions in Europe, regions, not cities, but the same more or less, are far higher than this target. So we understand that the cities as systems, with their inhabitants consuming for different reasons, by far more than in other big cities that are there, it is a matter of awareness and to a certain extent infrastructures, but to the very large extent is a matter of culture, is a matter of how the society actually addresses the problems and changes behaviors and attitudes. These are the famous Sustainable Development Goals, 17 of them, with 169 targets, and all of them are interlinked, and the important for different, for example, water, which is 6, or biodiversity and others, are linked with the climate action number 13. And we need to understand this interconnectivity in among the different goals, and see how we can synergize among different policies and actions towards a better future environment as it concerns climate change. The lack of awareness, as I said, or the lack of or erratic education is in the root, and of course it is the mistrust to political leadership, ignorance, distance from reality that sometimes is augmented by the new media, social media, and all that is what makes the appropriate education on climate change, and particularly education for sustainable development and global citizens education, absolutely necessary. This is the area where education has been recognized as of great importance. It is among the 3 solutions for climate change and loss of biodiversity: the lack of food, water and housing, and for health and disease. But it is also a top solution for all other major issues like violence and conflict, discrimination and inequality, disinformation and freedom of expression, lack of decent work and opportunities, political participation, democratic principles, artificial intelligence and new technologies, where PARCCE also takes into account, and traditions and culture which are at risk. The consortium members of PARCCE were called together for the creation of the necessary material and also the transformation of the material which I just had the opportunity to present to you, enriched and transcribed also with augmented reality in order to make it even more effective in our contact with our students. Thank you very much for your attention.